Francesca is joining us and she's going to talk about MLOps for continuous learning. Hi, Francesca. How are you?
I'm great. Thank you. Thank you so much for inviting me. I'm very excited to be here today and talk a little bit more about MLOps, machine learning operations for end-to-end solutions on the cloud.
That
Can
sounds
I
like
share my screen, or please let me know when I can share my screen?
Now, first I want to ask you if you can introduce yourself for a bit before we start, and then the floor is yours.
Absolutely. Thank you so much. Yes, so my name is Francesca Lazzari. I work at Microsoft as a principal data scientist manager. And at Microsoft, I lead a few teams of data scientists and machine learning engineers. And we work actually with internal customers. So we work with the Microsoft data and we build end-to-end machine learning solution to support different business areas at Microsoft. I'm also an adjunct professor at Columbia University, where I teach machine learning. And yeah, that's pretty much about me. I'm based in Boston, Massachusetts.
Okay. Sounds like you have a very cool job.
Yeah.
Yeah.
I think so. I feel very, very lucky, actually. So
Yeah.
I do think that my job gives me the opportunity, first of all, to work with a lot of talent people. That is, the best thing I can ask for. And second, of course, I'm always exposed to many different problems that can be solved with data. And so really the role of my teams and including myself is really to look at these different data sources, data pipelines, and try to understand if there are better ways to extract knowledge, to extract insights from that data in order to improve our customer experiences on the cloud.
Yeah. Yeah. Sounds cool. Okay, so are you ready?
I'm ready, of course.
Okay.
Thank
Good
you.
luck.
I just wanted, to test the Teams and see if it was working. Let me start sharing my screen.
Okay.
And let me know when you can see it.
Yes.
Great. Okay. So
Yeah,
let's get
it's coming
started
through.
and let's learn a little bit more about MLOps for continuous learning. As I said before, my name is Francesca Lazzari. I also added here my Twitter alias, so feel free to also reach out after this session if you have any questions on machine learning, data science, MLOps, and the cloud. But let's look together and let's try to understand together why it is so important nowadays to talk about machine learning operations, that is MLOps. So there are a few reasons why it's important to think about machine learning operations not just as a tool on the cloud that customers can leverage in order to have an end-to-end solution that is sustainable and scalable. It's not just about that, but it's actually a cultural mindset that you need to actually establish in your teams, in your organization. So as you know, there is the machine learning lifecycle has a lot of limitations, and there are also a lot of opportunities in terms of data, model parameters, features, monitoring, and also debugging. Machine learning models rely on a huge amount of data, and it is very difficult for a single data scientist in your organization to keep a track of all of it. And also in terms of model parameters, it's very difficult to keep track of all the parameters that we tweak in machine learning models. Then in terms of features, data scientists need always to keep track of the features for their models, machine learning models, and then monitoring. Monitoring a model isn't like monitoring a deployed software or web app. And so there are additional tools that I want to share with you today, and more like tips and tricks that you can leverage in order to improve the monitoring of your deployed and operationalized models. And finally, debugging. Troubleshooting, of course, models, machine learning models, when they are not really performing, and it's a very complex scenario. And so there are, again, some tools and a set of open source also framework that you can use in order to debug quickly your machine learning models. First of all, let's try to understand what are the different machine learning operations capabilities. And then together we will look at the open source integration, the machine learning pipeline, and the ML flow, which is a very powerful tool that you can use in order to build these MLOps culture and a set of tools in your organization. So let's start with machine learning capabilities. First of all, when you think about machine learning capabilities, you need to understand that it is important to create reproducible, scalable machine learning pipelines, because machine learning pipelines allow you to define repeatable and what I also call the reusable steps for your data preparation, training, and scoring processes. Then you have to also create reusable software environments for training and deploy your models. The other important aspect that you need to be aware of is that you need to know how to register, package, and deploy models from anywhere. And you can also track associated metadata required to use the model. And this is going to help you then with the debugging part of this cycle. And then it's also important nowadays, of course, to capture the governance data for the end-to-end machine learning lifecycle, notify and alert on events in the machine learning cycles, and finally, also monitor machine learning application for operational and machine learning related issues. So this is what I called machine learning capabilities. It is a set of capabilities that you always need to think of every time that you deploy and operationalize any machine learning model on the cloud and also in your own environments. The second part that is also extremely important is to be exposed to open source tools and how you can integrate those open source tools with your own environment. So let's try to understand a few set of tools that I have been using now for a while, and I found them like extremely helpful. So there is the training of open source machine learning models, frameworks for interpretable and fair models. And finally, there are some open source tools that you can use for model deployment. Let's start with training open source machine learning models. There are 3 frameworks that I have been using a lot for different machine learning solutions that I build. Those are PyTorch, TensorFlow, and Ray. Probably you are all very familiar with TensorFlow because it has been around for a while, but in the last few years also PyTorch has become like one of the tools that the data scientists and machine learning engineers really love in order to build their scalable machine learning solution. And then Ray. Ray is reinforcement learning. But let's start with PyTorch. PyTorch is an end-to-end machine learning framework, and it's great because there is this torch server that is at the core of PyTorch and is an easy-to-use tool for deploying PyTorch models at scale. And the PyTorch is very nice because right now it's very well supported on multiple cloud platforms, and it's great in order to also build solutions that are like a little bit more advanced deep learning solutions. There is a TensorFlow. TensorFlow is extended is an end-to-end platform for preparing data, training, validating, and deploying models in larger production environment. There is this TFX pipeline that is a sequence of components that implement a machine learning pipeline, which is specifically designed for scalable and high-performance machine learning tasks. And finally, I was mentioning Ray. Ray is great every time that you are building a solution that is based on the reinforcement learning approach. In terms of libraries, there are many different libraries for taking machine learning and distributed apps to production. So it's a great tool, open source tool that you can leverage again when you need to develop reinforcement learning applications. In terms of fairness and interpretable machine learning, these are, of course, a concept that are right now extremely important in the machine learning field because, of course, you as a data scientist, but also as a final consumer of machine learning application, you want to be able to understand why your machine learning applications are producing specific results, and also you want to make sure that you are able to implement those tools that are telling you if your solution and the data that you're using for your solution are fair. And so there are two open source tools that I have been using a lot for our own applications. The first one is InterpretML, which is a package that incorporates state-of-the-art machine learning interpretability techniques. And with this package, you can train interpretable glass box models and also explain black box systems. And then there is a FairLearn. FairLearn is, again, another open source Python package that has two main components. The first one is around the metrics for assessing which groups are negatively impacted by a model, which groups of also users and customers. And the second one is about algorithms for mitigating unfairness in a variety of AI tasks, along with a variety of fairness definitions. So again, make sure that you always incorporate those packages as really part of your data science lifecycle or machine learning lifecycle. The third aspect that I wanted to share with you today is related to model deployment. Of course, every time that you train, test, and validate your model, then you need to pick the best model for your solution, and you need to operationalize this model. And this is extremely important for data scientists, for machine learning engineers. And so one open source tool that is really helping right now data scientists and machine learning engineers with this aspect of the life cycle is Onyx. When you, as a data scientist, you're working with different frameworks and tools, it means that you have to deploy models according to the framework's requirements. And to standardize this process, you can use the Open Neural Network Exchange. This is Onyx. That is a format that is really helping you with that. You will always find yourself in situations where you're working on a solution and you're using multiple frameworks. And Onyx is going to be that type of connector that is going to allow you to deploy your models. So what is specifically Onyx runtime, what we call also ORT? Onyx is an open format built to request machine learning models, and Onyx defines a common set of operators, the building blocks of a machine learning and deep learning models, and a common file format to enable developers, again, data scientists, machine learning engineers, to use models with a variety of frameworks, tools, runtimes, and compilers. Specifically, inside Onyx, there is the Onyx runtime, that is, as I was saying before, ORT, that is there to optimize and accelerate machine learning inferencing and training. So as you can see from the next slide, it's really great because it's a framework that is freedom, that allows you as a data scientist to have that freedom with a common interface for multiple deployment targets. Converting to an Onyx model is really easy independently from the different framework that you are using. Again, I have been working with data scientists who have been using TensorFlow, Keras, ML.NET, MathWork, PyTorch. Before, in the previous slide, I was showing you the three main open source frameworks that I have been using, like PyTorch, TensorFlow, and Ray. But honestly, there are so many others. And then when you get to the model deployment, to the model operationalization, the conversion that you can do from these frameworks to the actual deployment of your model is actually pretty easy. Here, I share with you a few examples on how you can implement this model conversion. As you can see, you can take either Keras or PyTorch, and then with just a few lines of code, you can just load the model and then convert the model into, like depending on the frameworks that you are using, and then also you can export the model so that you can have that file that is containing your model deployed. So Onyx is really probably the tool that I use now the most when it gets to machine learning model deployment and operationalization. Moving on with our MLOps for continuous learning cycle. So we saw the MLOps capabilities and what I mean when we need to learn those capabilities in order to be able to implement them once we deploy our machine learning models. We saw a few open source integration options in terms of tools that you can use from model training and also machine learning fairness, machine learning interpretability, and then the deployment of your machine learning model. And now let's look at another important concept that you need to be exposed to if you want to implement MLOps strategy in your data science organization. This other concept is extremely important because data preparation, including importing, validating, and cleaning transformation of your data, needs to be done inside this machine learning pipeline. And training configuration, including the parameterization and also the inclusion of arguments, file paths, and logging configurations need to be part of these machine learning also pipelines. And then machine learning pipelines need also to include and to think about training and validating efficiently and repeatedly your models. And finally, these include also the deployment of your machine learning models, including versioning, scaling, provisioning, and access control. So these are really the set of tasks that the pipelines should look at when they are created, because from data preparation to training configuration, of course, you need also to training and validate your model, and finally, you need to deploy your model. All these steps are part of what we call the machine learning pipelines. Very often when I work with customers, they always ask me, which pipeline technology should I use then? And so that's why I created this simple table where you can see that there are different scenarios, of course. And here I try just to summarize some of them. Some scenarios, for example, for model orchestration that is really focusing on machine learning. The primary persona for this is usually a data scientist, and the open source offering that you can use is a Kubeflow. For the second scenario, as you can see, there is a data orchestration. The primary persona for this is the data engineer, and one of the open source offerings that I have been using a lot is Apache Airflow. And finally, for code and application orchestration, that is more CI/CD, this is the persona, most of the time, the persona that is actually working with this scenario is an app developer. And I have been using a lot Jenkins. And again, depending on the specific scenario you find yourself in, and also the type of professionals you're working on, there are many different open source tools that you can use, you can leverage in order to build your machine learning pipelines. The last concept that I want to introduce today for the MLOps for continuous learning cycle is called MLflow. MLflow is both a concept, but I would say is also a tool. Is another tool that I have been using a lot for MLOps capabilities. And it is a tool that is based on 4 different components: MLflow tracking, MLflow projects, MLflow models, and MLflow registry. Let's quickly see all of them. So MLflow, as I said, is an open source platform for managing end-to-end machine learning lifecycle. it tackles four different primary functions. The tracking experiments to record and compare parameters for results, and also in order to improve the results that you are getting from your machine learning models. Then there is also the different MLOps tracking capabilities. This is more like an API and a UI for logging parameters, code versions, different metrics, and different artifacts when you're running your machine learning code, and for also later visualizing the results that you're getting from your machine learning models. MLflow projects, these are a standard format for packaging reusable data science code. And it's very nice because each project is simply a directory with a code or with a Git repository. So it's really great when you want to reuse your data science code. Then you can see that there is a MLflow models. These offer a convention for packaging machine learning models in multiple flavors, and also is a sort of a variety of different tools that help you to deploy your machine learning models. And then finally, there is MLflow registry that offers a centralized model store and also a set of APIs and UIs to manage the full life cycle of your machine learning model. So this is again a great set of 4 different steps that you can use in order to implement end-to-end machine learning solutions, and also be able to maintain those solutions from an operations point of view. Finally, I want just to leave you with a few references. Here, there are a few great articles, resources, and also all the open source tools that I share with you today. And so if you want to learn more, for example, about Fairlearn, InterpretML, Onyx, here you find all the resources that I use for my work and also for this presentation. Thank you very much. I hope you learn more about MLOps capabilities, and please let me know if you have any questions. Thank you.
Thank you so much, Francesca. Great presentation. Really, I learned a lot from it. We have a couple of questions for you. The first one, is Onyx recognized by typical registry servers such as MLflow and Azure ML?
Yes, it is. This is actually a very good question. The fact that I started using Onyx a lot because it's very well integrated on Azure machine learning, and so you can use it honestly anytime that you're using a Python-based framework for developing your machine learning deep learning solution. Then when it gets to the deployment of your machine learning models, you can use Onyx, and so you can be on different clouds independently from the cloud provider that you are leveraging for your solution. You can use it, and I personally have been using it a lot on Azure, and so with Azure machine learning. This is a very good question, and it's probably one of the first questions I ask to the product team that was introducing this integration, because I'm really keen about using open source tools also on the cloud, and so that is one of the reasons why I start using Onyx.
Okay, so it's very well supported across different clouds, and okay, sounds good. Which basic models can we learn if we want to start a career in AI?
Wow, this is another great question. So I would say if it depends a lot on the type of role that you want to have in the AI industry. I would say that at the beginning, when I started more than a decade ago in working data science, machine learning, AI, you had to be like a data scientist. So you had to be a person with a strong statistics and mathematical background, and you had also to know how to code in R, Python, also using like SQL for the ingestion of your data. However, nowadays there are multiple roles that you can actually get if you work in the AI industry. I'm thinking about machine learning engineers, data engineers. I'm also thinking about machine learning researchers, data scientists, of course, but also product managers that are, more like the people who help develop the tools that data scientists and machine learning engineers are going to use. So I would say it really depends on the type of role that you want to have. If you ask these questions specifically for data scientists, I would say they really start with learning very well how to use Python for machine learning. And after that, you learn like how to build simple models. I would always recommend my teams of data scientists and machine learning engineers to start with simple models like regression, classification. But then the most important part is really about getting familiar with those frameworks that are right now used a lot in the industry to build machine learning models and solutions. I mentioned some of those today, like TensorFlow, PyTorch, Ray. And the more you get used to those frameworks, the more you will learn how to tackle some of the most complex problems with the data and build your solution on the cloud. Yeah, so that is my recommendations for you.
Very good recommendation. I think I will follow that one as well to get more into it. Thank you. We have one more question. If you want to start with MLOps in your organization, what profiles do you need to add to an MLOps team? Because I see lots of customers struggling with this.
Yeah, that's another great question. I would say that, today I hope that with my presentation you got a very good overview of what are the options that you have as a developers, as a data scientist to implement a MLOps strategy around your organization, around, your data science solutions. However, I understand that it depends a lot on the type of problems that you're trying to solve. So always try to think about MLOps again as more like a cultural environment, or like I would say probably a mindset that you need to establish across your organization. MLOps is not something that can be done in a silos by just one or a few data scientists, but it's really a cultural change that you need to establish across your organization. And so start to think about machine learning not just as a machine learning model in a Python notebooks, but start to think about machine learning as an added value to the business or to a specific scientific areas that you are contributing to. Because if you think about machine learning in this way, then you are going to think about AI application or machine learning solutions as real tools that can improve our life, which is totally true. And so if you think about this, you immediately start thinking about how I can make sure that those models stay accurate. There is, of course, a refresh of the data, and they can consume the results from those models over time without spending too much time debugging, refreshing, or like manually improving them. So if you start to think about the life cycle and the real life of a machine learning models, then you will start thinking about the tools that you can use in order to make sure that that life cycle is supported over time. And by thinking in that way, then you will try to find like some of the tools that are the best tools for your own use case. Again, it's possible that you're working already with TensorFlow, with PyTorch, with Ray if you're in the reinforcement learning field. And then based on those frameworks, you will need to find a tool that is helping with your deployment, and that can be Onyx. And then some of those additional tools like MLflow that are helping with also packaging the model or helping with the registry of your model. So think really about the end-to-end life cycle, and based on your specific scenario, of course, there are the best tools that you can use, and think about how you can connect all of them to maintain the life of your model. And so if you think, I think in that way, also the potential of your machine learning models then are really not going to find any limits because you want those machine learning models to be accurate, but most important, you want them to be scalable and extensible also to other scenarios that you can support over time.
Yeah, totally true. Yeah. We have a couple more questions. Let me check.
I think we'll need to start going to our next speaker also.
Is it already time?
Yeah, it's time.
Oh, okay.
But
we have some questions in the chat. Are you available to answer them after this session?
I think Yes,
okay, that would be great.
Yep.
Okay, thank you.
Thank you so much.
Thank you so much for your session. Really interesting.